Good day, everyone. You are welcome to Omotayo Akintunde YouTube channel. The data set we have on the screen, I want to run and analyze them to know the variation within and between the two groups. The two groups are teachers' experience and teachers' content knowledge. I will be using one-way ANOVA because it has one independent variable, which is the teacher's experience. This will tell us if there is difference within and between the two groups. One can use different kind of software packages to run this kind of data. Software packages like programming language, example of programming languages could be Python and so on and so forth. Software package like R, SPSS and so on and so forth. But I will be using SPSS software package. As we can see on the screen, the value for teachers' experiences are in 4 categories. As you can see, 1, 2, you can see 3, you can see 4. Are be categorized into 4 scales. Teachers' content knowledge are not categorized. The data are continuous. So that shows teachers' content knowledge is a continuous variable here, while teachers' experience is a categorical variable. The data we have on the screen, as you can see, they are whole numbers, 1, then, and they are well set. I want to copy them to go and paste them on the SPSS interface. To do that, I will highlight them. I will highlight all of them. Highlighting. As you can see, we have, okay, sorry, I'm not meant to highlight the number, the serial number. You don't need the serial number because the SPSS will give us the serial number. Yes, we have highlighted. So the next thing is to copy. I select copy. Then let's go to SPSS interface. We have opportunity to enter as many variables as we have, but we have only 2 variables to run and analyze, and we are using these 2 columns. So I pick the first column. I want to paste the data. I paste the data. As you can see, the data has been displayed. No more in whole number, but they are in decimal places, 2 decimal places. Detail to the name of the variables, display variable 1 and variable 2. Instead of teacher's experience and teacher's content knowledge, you can do the necessary adjustment at variable view. At the variable view interface, we need to change. I will change this to teacher's experience. Teacher's experience. SPSS is not compliant with space at this column, so we are going to use underscore to accept underscore. Experience that's accepted that teacher's experience. Detail to variable 2. Variable 2, we shall name it as teacher's content knowledge underscore content underscore knowledge underscore knowledge. That's accepted that. So now move to type column. On the type column, you will see that the name, the kind of variable values that we are given are in numeric form. They are not in alphabetic form. So since they are in numeric, we leave it as it were. Then move to decimal. The data given has changed to 2 decimal places, so I will change it to 0 decimal place to take it back to whole number. They are now in 0 decimal place. Then on the label, I will now write the name of the variable 1, which is teacher's experience, without the underscore to accept space at this column. Teacher's content knowledge to accept space at this column. Experience rather. Teacher's experience is the first variable. Experience. Then the last one is teacher's content knowledge. Teacher's space content. content knowledge. That's accepted that. Then now to value column. We see that teachers' experience are be categorized into 4 scales respectively. This will be coded here. We are going to code them here. Thus, then we open this place. You can see now we now have value label. So we shall assign value for each of the categories. So I will assign value 1 for the first category. Then I label it as 0 to 5 years of experience. Years of experience. Then I select add. Then the second shall be assigned value 2, 6 to 10 years of experience. 10 years of experience. Then I select add. So the next one shall be 3. The label shall be 11 to 15. 11 to 11. 11 to 15 years of experience. Years of experience. So I select add. So the last but not the least is the 4th category, which shall be 16 to 20 years of experience. Years of experience. They are select add. So we have assigned values to each of the categories of the teachers. Then on the teachers' content knowledge, if they are not categorized, they are continuous data. So it's a continuous variable. We leave it as it's where. Then move to measure column. On the measure column, when we pick the first column, we can see that we have option of picking from teachers' scale, ordinal or nominal. We see that teachers' experience will be ordinal because there is superiority in the years of experiences of teachers. Teachers graduate from classroom cadre to administrative cadre. That shows there is seniority, there is superiority. So that will be ordinal. Then on teachers' content knowledge, we have 3 options as well. Teachers' content knowledge is not nominal nor ordinal but scale because the data given are continuous. Continuous data could be ratio or interval, but SPSS didn't give room for ratio or interval. It has codenamed it to scale. So we are going to pick scale for that. Let's now view our data. We will see that the data has changed to whole number and the name of the variable has shown. So the next thing now is to run the data at hand. So we go to analyze. As we know that I want to compare the mean between the 2 groups, so we select compare mean and I say I want to run one way ANOVA. We select one way ANOVA. It has given us another interface. On this place we have the dependent list, which is the dependent variable. So teachers' content knowledge is the dependent variable. So we select it and put it in the box. Then we have factor. Factor, teachers' experience it represents factor, which is the independent variable. So we need to run the descriptive of the data set to give basic feature of the data set. So I go to option, I select descriptive to give basic feature of the data set. So I also need to pick homogeneity of variance test. To test is constant across the group. Then if you look at the confidence interval level, it's at 0.95, which is correct. So I select continue. Then let us see the output of the result. I select OK. Yes, on the output we have descriptive table, we have homogeneity of variance, and we have ANOVA. On the ANOVA table, we will see that the ANOVA shows us that the F statistic value gives us 12.387, significant at less than 0.001, and P less than 0.05, which is significant. Since it is significant, we are now going to run the post hoc test to know which of the groups will differ. So I will go back as a revision for us to the SPSS interface. Move to analyze as a revision for us. Compare mean, move out. Then now pick one way ANOVA. It has given us the interface back. Like I said, we want to run the post hoc to know which of the group will differ. Yes. At this point, we can either run it through Bonferroni or SIDAC or Scafe or Turkey, or as many as you want to pick from here, or Duncan, but I want to pick Scafe. Then I select continue. I need a more robust information on the output of the result. I want to pick a means plot to give us graphical presentation for further clarification. As I selected means plot, then I select continue. It will give us output. Okay, I've not selected okay to give us output now. You can see that it has given us additional output. As you can see, it has given us additional output, as you can see on the screen. So we are now going to analyze and interpret each of the table. So I will start from the descriptive table. On the descriptive table, we will see that the descriptive table shows that teachers with 0 to 5 years, they are 43 in number. 6 to 10 years, they are 36. 11 to 15 years are 13. 16 to 20 years are 8. When we add everything together, give us 100. That shows the data are intact. No data got missed along the line. If you look at the second column, we have value for the mean and value for the standard deviation. The descriptive table shows that teachers with 16 to 20 years of experience has the highest mean value of 32.00, as we can see on the screen. This means this set of teachers has more favorable or desirable value. This proves to us that they have very high proficiency in the content knowledge. The second in main rank is teachers with 11 to 15 years of experience, as you can see on the screen, with mean value of 31.23 mean. This also shows a high proficiency in the content knowledge. The third is teachers with 6 to 10 years, as you can see on the screen, with mean of 30.22. This set of teachers shows as display and average proficiency in the content knowledge. The last but not the least is the fourth rank is teachers with 0 to 5 years of experience with mean value of 25.68. This implies the teacher has low proficiency in the content knowledge. When we now further move to the next table, the next column, which is standard deviation. Furthering, when we consider the standard deviation, teachers with 11 to 15 years of experience has mean value of 2.78, which is the least among the fourth group. 2.743, which is the least among the fourth group. This is closer to the mean, indicating less variability or dispersion, and more consistent, which is the best in terms of teachers' content knowledge. This is followed by standard deviation of teachers with 3.071 of 16 to 20 years of experience, as you can see, and then standard deviation of 3.965 of teachers with 6 to 10 years of experience, and finally standard deviation of 4.481 of teachers with 0 to 5 years of experience. From the value we have for the mean, 32.00 as the highest, then 2.743 as the least mean standard deviation value. Highest mean and lowest standard deviation shows a high average value, consistent and reliable. With this variation, it shows teachers' experiences, classroom management, student-teacher interaction or relationship, and so on and so forth could be the factors that are responsible for their variance in mean and standard deviation. Now, we shall now conclude at this point in time that this outcome suggests that experience should count in allocation of teachers to classes. Direct deduction from the aforementioned outcome recommend that The beginner and terminal classes should be manned by teachers whose proficiency in content knowledge are very high or high for desirable learning outcome. Let's move to the next table. The next table we want to analyze and interpret is test of homogeneity of variance. From what we can see on the screen, we can see equal values on this table. Teachers' content knowledge based on teachers' content knowledge based on mean degree of freedom 1 give us 3, based on median degree of freedom give us 3, based on mean and adjusted degree of freedom give us 3, based on free mean also give us 3. Teachers' content knowledge based on median give us 0.87, based on median and with adjusted degree of freedom also give us 0.487. Ditto to degree of freedoms 2. The teacher's content knowledge based on mean give us 96.96, based on median give us 0.96, ditto to based on tree mean give us 0.96. At the significant level, teacher's content knowledge based on median give us 0.692, and based on median and with adjusted give us 0.692. What this is telling us that it shows that the variance of teacher's content knowledge, which is the dependent variable, is equal across the groups. Let's now interpret the ANOVA table. On the ANOVA table, we will see that the degree of freedom we have here, we have 3, 96 and 99. How do we get the 3, 96 and 99? Between groups, we have 4 categories. The independent variable has been categorized into 4. That is between groups. We have 4 of them. So when we have the formula for degree of freedom is n minus 1. When we subtract 1 from 4, it will give us 3. Within groups, the total number of data sets we have is 100. When we subtract 3 from 100, it will give us 97. The formula for degree of freedom, n minus 1, 97 minus 1 will give us 96. By the time we add 3 to 96, will give us 99. On the F statistic, it is this table itself is a single measurement of the teacher's content knowledge. The F statistic value tell us how much variance in the dependent variable is explained by the independent variable. As we can see, the value of this table gives 12.387. This is higher value. It shows a higher effect. Now let's move to the significant value. The significant value gives us 0.001, which is at p less than 0.05. It shows the effect is significant. This reveals to us that there is difference among the groups, meaning it is statistically significant. That shows teachers' experience predates teachers' content knowledge. For documentation's sake, if you want to write this down, you open a bracket for the F to write this value for the F statistic. You open a bracket, F subscript small letter 3 subscript 3, 96. We close the bracket equals to 12.387 semicolon p less than 0.05. Now let's compare the multiple comparison. Let's go to the table of multiple comparison. Table of multiple comparison to put all tests. On the multiple comparison, we will see that teacher want to compare the different means of experiences of teachers from 0 to 5 years and 6 to 10 years give us minus 4.362, and then when we compare it with teachers with 6 to 10 years and 0 to 5 years as we have here, we have plus 4.362. When we combine the mean difference to give us 0.00 at p less than 0.05. When we now compare 0 to 5 years and 11 to 15 years of experience of teacher, give us minus 5.370, comparing with 11 to 15 years and 0 to 5 years give us plus 5.30. When we combine the two mean, it will give us 0.00 at p less than 0.05. Due to 0 to 5 years of experience and 16 to 20 years of experience give us minus 6.140, and when we combine it with 16 to 20 years of experience and 0 to 5 years give us plus 6.140. When we combine the mean difference, it will give us 0.00 at p less than 0.05. When we now compare the mean difference of 6 to 10 years and 11 to 15 years of experience give us minus 1.009. When we compare it with 11 to 15 years and 6 to 10 years of experience, will give us 6 to 10 years of experience and 11 to 15 years. Combine 11 to 15 years and 6 to 10 years give us 1.009. We combine it with mean difference of minus 1.009 give us 0.00 at p less than 0.05. We now combine the mean difference of teachers with 6 to 10 years of experience and 16 to 20 years of experience give us minus 1.778. Combining it with 16 to 20 years and 6 to 10 years give us 1.778, as you can see on the screen. When we combine this mean, give us 0.00 at p less than 0.05. When we compare the mean difference of teachers with 11 to 15 years of experience and 16 to 20 years of experience give us minus 7.69. Combining it with mean difference of 16 to 20 years and 11 to 15 years of experience give us 0.769. At this point in time, we will now conclude that this shows that the mean difference is statistically significant at 0.05 level of significance. When we interpret this is telling us that teachers' experiences have a significant impact on the teacher's content knowledge, or one can say that teachers' experience significantly affect teachers' content knowledge. Let's now move to the main plot. On the main plot, this gives the graphical representation of the mean value of teachers' content knowledge across the level of teachers' experiences. Now, from the plot, we can see that there is relationship between experiences of teachers. You can see that there is relationship between the experiences of teachers. The higher the experiences, the higher the scale value. As the experiences increases, the scale value also increase. Let's look at it one after the other. 0 to 5 years give us the mean content knowledge of teachers to be 25.86. 6 to 10 years of experience give us mean teachers' content knowledge of 30.22. Due to 11 to 15 years of experience give us mean value of 31.23. We can see that its progression is moving higher from 25.86, moving the scale, the graph is moving higher. The last but not the least is teachers with 16 to 20 years of experience has a mean value of 32.00. Combining the two together, we see that there is progression in the graph due to the scale, due to the years of experience. Conclusively, direct deduction from this plot recommend that beginner and terminal classes should be handled by teachers whose proficiency in content knowledge are very high or high for desirable learning outcome. From what we have now and all the analysis we have done so far, teachers' experience has a significant influence on teachers' content knowledge. One can recommend that beginner and terminal classes should be handled by teachers whose proficiency in content knowledge are high or very high for desirable learning outcome. Experience should count in allocation of teachers to classes for positive academic achievement. Thirdly, teacher professional development should be encouraged among teachers to deepen their content knowledge. The fourth recommendation is that there should be in-house workshop for teachers with less experiences, and arrange internal and external seminar, workshop and conferences to boost their exposure and retooling of their knowledge and skill. With this at hand, less experienced teachers' content knowledge will be deepened and wide. Then experienced teachers too will be developed continually, and not experienced burn out or become dead wood. Thank you for your audience, and God bless you.